All right, then let's start with carbon and its compounds. You have your notebook with you? So let me give you a little brief about this chapter. Let me brief you about this chapter. So, like from the name only, you can guess like this chapter is going to surround, will be related to carbon only. So, first we'll study a little about carbon. So, carbon is basically a naturally occurring element. Okay, like it's not manufactured by humans; it's a naturally occurring, and the symbol for this carbon is C. It's represented by C. It's a non-metal. Um, yeah. So this carbon is a non-metal, a naturally occurring element. And so we'll study a little about its properties, how it forms other elements. And in this chapter, this carbon also forms its own compounds, right? So this compounds means it's joining with itself, like a carbon chain. Basically, when two or more carbons are joining together, this means this is a bond. That means they are joining together, right? So this is a bond, or that means they are joining together. So basically, you'll in the compounds part, you'll learn that how carbons join together to form a new substance, a new compound, or how carbon may join with some other element to form another compound. Okay, that's what this chapter is going to be about. But let's start with this carbon first.
Ma'am, is it also called chain?
Yes, a carbon chain.
Okay.
Only when if it's a chain, then no other compound should be there. Okay, a carbon chain means carbon, 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 and so on.
Ma'am, then bond is?
A bond is basically when this carbon is joining the other carbon. So they have a bond in between. So this is the bond. Okay, like basically a link that's joining both the carbons. That link will be called as bond.
Ma'am, can any other element join with carbon and then it's called bond?
Yes, yes. Bond is for every element. Like if any two same elements join, then they're forming a bond. If some two different elements are joining, then it will also be it will also called a bond. And if carbon is joining with some other element, then it will also be called bond. Carbon
Okay.
joins with, you might have heard about organic chemistry. So carbon, when hydrogen and carbon join, like there are a lot of compounds, a whole lot. There's a whole subject in chemistry, organic chemistry, in which you'll study about this carbon and hydrogen joining together, forming new compounds. So the carbon also joins with other elements like hydrogen is the best example to form new compounds. Okay, so that means the carbon and hydrogen are bonded here, and these bonds are also of different types that you'll study in like upcoming chapters. Okay.
Okay. Ma'am, so basically chain is when a carbon joins with a carbon.
Yes. And a
And
bond.
bond
Mhm.
is when carbon joins with any element or itself carbon only.
Yes, basically a link between the two elements that is called a bond. Yeah, so we were so first carbon is represented by, like, the symbol for carbon is C. It is a non-metal. It is naturally occurring element. So it occurs naturally. I'm also like defining what an element is. So basically, substance, when a substance cannot be broken into like further different species or parts, that's when we call it an element. So You can write that down also.
Mom, so carbon is the element?
Yes, carbon is an element.
Okay.
Um, do you know where we can find carbon? Like, where is it available?
No.
Okay, so it's available in atmosphere, right? Have you heard about carbon
Carbon
dioxide?
dioxide.
Yeah, right.
Yes,
So
ma'am.
it's also like a carbon plus oxygen. So it's a substance or a gas that is formed when carbon joins with oxygen. So that is where carbon is available. In the Earth's crust, like when you dig deep in the crust or in the soil, there also carbon is present. Also, it's present in like a large quantity, but still, apart from that, we have a large amount of carbon present in organic compounds. Like you might have heard about glucose, right? In your
Yes.
sugar, glucose, sucrose, all these things, carbon is there. So these naturally occurring organic compounds, and even in photosynthesis, you might have studied that glucose is also used. So that also contains carbon. uh, the formula for glucose, like the for see what formula is basically like for CO2, it's for carbon dioxide is it's CO2, right? But
Yes.
for glucose the formula is C6H.
C6H12O6.
Yes, C6H12O6. So carbon is also present there, C6H12O6. Similarly, in sucrose and a lot of other organic compounds, carbon is present. Have you written this down? Let me add this point also.
Did I write this formula? Glucose and carbon dioxide.
Yes, you can write.
Done, ma'am.
The point that I just explained about the availability, I'm writing that down, so you can write that down also. Like, is this still going on in your class, this chapter?
Yes, ma'am. Like the last part.
Okay. All right. So like all the living organism, whether they are plants, animals, we are all made up of just yeah. So we are all made up of carbon, right? In humans also we have 18% of carbon. We are made up of 18% of carbon, and even during photosynthesis, plants need carbon dioxide for their survival, right? They inhale carbon dioxide, so they are so carbon is also an essential requirement for them. Say just one more point, you can write it down. It's a little intro that's going on till now. Hmm. So I've written everything that I just explained, that we all have something carbon related, like a carbon compound or carbon inside us, like plants perform photosynthesis and inhale carbon dioxide, and we also have like 18% of carbon in us. Now this I have mentioned in this point, these compounds are called organic compounds, right? So this is the
Yes.
same thing I just mentioned. I mentioned organic chemistry being a whole subject because there are so many compounds that instead of did I get stuck? Should I repeat?
No, ma'am, you'll not get stuck.
Okay. So I was talking about organic chemistry, how it's so vast. The carbon and its compounds are so vast that like scientists have to had to make another subject for it, just surrounding the organic compounds. So these are the organic compounds. They basically occur naturally when carbon is bonded with carbon or some other element. Okay, and these are used in natural processes also. Okay. Now, I'm gonna write a few it's regarding the availability of carbon only, like how much is it present in atmosphere and in the earth's crust, because I mentioned here in this point that it's available in earth's crust and atmosphere. So in the atmosphere it is present 0.03%. So you can either write it down there only, it's present 0.03% in the atmosphere, and it's present in the form of carbon dioxide and carbon monoxide. So in the form, if you don't have space there, you can write it down and like make a next point. Like in the atmosphere, 0.03% of carbon is present. Or do you want me to write the whole point again?
No, no, that's right.
Okay, it's in the form of CO2, that is carbon dioxide. And see, how do you know the formula for carbon monoxide?
No, ma'am.
Okay, I'll tell you how to understand this. So carbon monoxide. So the
It
word,
means
sorry.
It means one oxygen with carbon, right? I guess.
Yes. Yes, exactly. So first we'll write the carbon. For carbon C, first I write the C. Mono means one, and oxide is the oxygen. So we don't need to add any number. So it's just CO, carbon monoxide. So and also it's harmful. Carbon dioxide is like we exhale it, and it also increases the global warming. But carbon monoxide is very harmful. Carbon dioxide is harmful, but carbon monoxide is extremely harmful. And in the Earth's crust, have you written the percentage here?
1 second.
Yeah, take your time. Done?
Yes.
Hmm. All right. Now, this was for atmosphere. Now, in Earth's crust, where did the Earth? Yeah, here. So, in Earth's crust, it is present in 0.02%. Whatever composition other elements are there in the Earth's crust, carbon is 0.02%. And that too, it in the form of, let me write it down, in the form of carbonate, carbonate, hydrogen carbonate, and you definitely have heard about coal and petroleum, right? So
Yes,
those
ma'am.
are also carbon's derivative and like products of carbon only, compounds of carbon. So like from there you can assume how much in how much quantity that carbon is present, because we use the coal and petroleum, basically the fossil fuels, in a large amount, right? All our fuels are from there, our electricity we get from there, steam engines. So carbon is present in a really large amount. So add coal and petroleum also here. I should have made a different point for this. Done. Okay. Now this was about like the availability of carbon and everything. Now we'll basically we have started the properties. So in this properties we'll look the way atomic mass, its size and atomic number, and everything about carbon. So first point is, should I add properties here? Now you can like write down properties of carbon. So our first point in this is going to be atomic mass. Do you know what atomic mass is? Like in general, not of carbon.
The atomic mass is the number each molecule has.
See, if it's got the word has atom, so the first point, let me write it down first. So it's atomic mass, and mass means basically something that's got weight, right? So
Yes.
an atom or an element has got its neutron and proton inside it, right?
Yes.
So when we add the protons and neutrons and then a number comes, that is basically atomic mass. So I will also write the definition here so that it doesn't create a confusion. All right. Also, like the symbol for atomic mass is A. Okay. Now, the atomic mass of one more thing, the unit for measuring, like the unit will be AMU, atomic mass units, or upon U weight. It's written as unit is AMU, and the full form is atomic mass unit. Or like instead of writing whole AMU, you will also see just U written. So for carbon, the atomic mass of carbon is 16. So how you're gonna write it as 16U. Okay. So
Oh,
that's where the unit comes in play. So you'll just write 16 AMU or 16U. So 16 is the atomic mass of carbon. Till here, is it clear?
ma'am, in the first point, what about electrons?
We don't count the electrons.
Oh, 10 ma'am.
Hmm. Now your question was, what about the electrons, right? In the atomic mass, we included protons and neutrons. But when it comes to the atomic number, that's where we count the electrons. So the total number of electrons will come in the atomic number. The second point of this characteristic is atomic number only. Atomic number. And size of the carbon. Okay, so when we talk about atomic number, it is the number of electrons present in an atom. Okay, and for carbon, it is 6. Okay. It is the number of electrons. So for electrons, I'm going to write E minus.
Okay.
How much did I mention about carbon? What is the atomic number?
6.
How much?
6.
Yes. So there are 6. So, and also like this was represented as A, atomic mass. The atomic number is represented as Z. So atomic number is represented as Z, and for carbon it's 6. 6 for carbon. Done? Okay, you're right.
But how is atomic mass different from atomic number?
Because you are adding it basically kind of the weight. Okay, and it's just the see, yeah, you're adding two different things, proton and neutron for the weight, and electron is separated. That's why.
Ma'am, in atomic number, only electrons are there.
Yes.
Oh. And in atomic mass, protons and neutrons.
Yes. Yes. I'll share one picture with you. You
Okay.
can draw that also. Just give me 1 minute. Just give me one.
Okay.
So this is a carbon atom. You can see 6 protons and 6 neutrons. And how, wait, I think it should have been electron, I guess.
Green is electron.
Yes, I think so too. Because why is it 6 or like 12 then? Hmm. It's correct. I wrote that wrong here. It's not 16. I mixed the 6 and that. It's 12 only.
Oh,
The mass is 12. That was on me. So the mass is 12 and 6 of the electron is also 6. The electrons, you can see the green ones are the electron here. So 1, 2, 3, 4, 5, and 6. These are all rotating and revolving. Um, Not rotating, revolving around the nucleus. And the protons, you can again see 1, 2. Let me change the color. 1, 2, 3, 4, 5, and 6. And the neutrons, these were the protons. Neutrons are also 1, 2, 3, 4, 5, and 6. So on adding this 6 and 6, we're getting 12. That's the atomic mass, 12U. Also, it because they are together, right? That's a collective mass. So that's why they are taken together, whereas electrons are far apart and they're continuously moving. That's why. Also, these are fixed. Your question was like, why are we not adding electrons in atomic mass, right? Why are not electrons included here? Have you heard about right? You have the example I shared about water, right? How the sharing occurs, or an element can give its electron to other element in oxidation state. You have also studied that elements have the capability of giving an electron. So if
yes,
this electron is going to go away, that will affect the mass, right? But the mass or atomic mass remains constant. It remains constant because that's why we don't involve electron, because it has to be constant. And if we involve electron, then it will keep on changing, right? If it the atom gets 1 electron, then it will change. Or if 1 electron goes away from this atom, it will change. So in order for that, that's why we don't include this electron. Is that clear?
yes.
Okay, you can draw this.
Ma'am, then isn't it atomic number will keep on changing?
No, it won't change.
Should I draw this?
Yeah, draw this.
Ma'am, in atomic number, we involve only the electrons, right? So electrons also keep gaining and losing. So how does it not change?
Am I audible?
Yes, ma'am.
Okay. So you're asking, wait, I actually don't know the answer for that, but it's fixed. I'll give you the answer in a minute, but it does not change. I know that it does not change, but I'll tell you the answer for that. Shall I continue?
Yes, ma'am.
Okay. So now the next part or the next property is electronic arrangement of carbon. Yep. Have you heard about shells and valence electrons?
Yes, ma'am.
In the previous standard, you might have learned, yes. Can you tell me how many shells are there in this? Like from this figure, you can only tell.
There are only two shells.
Two shells. Can you name those shells?
Mm. Um, they are KMNL shell.
Hmm. Okay. Let's start with writing. There are two shells in this carbon atom. There are two shells in the carbon atom. Now, when we start counting the shell, we start from the very inside. This is K, L, and if there was one more shell, then M, and even one more, then N, right? But we have two, so we don't, in this, we have two shells, so we don't need M and N, so I'm going to erase that. So we have two shells, right? And in
Yes.
M, we have two electrons, and in N, sorry, in K, we have two electrons, and in L, how many electrons do we have?
Four.
Four. The number, no, number of electrons. So shells and number of electrons. So in the shell K, we have two electrons, and in shell M, we have four electrons. Now, can you tell me how many valence electrons are there?
Um, Six.
No, no, no. See, the six is the total number of that are present. Total number of
Oh,
electrons that are present. Valence electron are the electrons that are in the outermost shell. So for
four.
this atom, the outermost shell is L. There's no other shell after this. The
Yes.
outermost shell is L. So in L, you can see one, two, three, and four electrons. So so carbon has four valence
Four.
electrons. This sorry. This is a very like important question from here. When just okay, let me write this down first. So carbon has four valence electrons. Now four can also be called as tetra, right? Four valence electrons. So
Oh,
so we can also call it that carbon is tetravalent. That means it has four valence electrons. So therefore carbon is tetravalent. And there might like some questions in your exams, a question might come like explain why is carbon tetravalent. So you can simply explain that because there are total six electrons in carbon, and in the outermost shells four electrons are available, and therefore it is tetravalent. Okay. So yeah, so valency of okay, so tetravalent. In this, like, also make this in that figure you just made, you can write this K and L, also include the K and L.
done.
Okay, so now the next now we are done with, like, it has four valence electrons. Now from valence we come to the valency. Have you heard about valency?
Yes, ma'am.
What is valency?
Ma'am, the electrons present in the last shell.
Yes, same as valence electron. So the valency is basically the number of a- electrons in the outermost shell. So can you tell me what will be the valency of carbon?
4.
Yes, because they are. I think I've already included that. I'm not going to make it another point. Okay, let's make it. Also, the number of electrons in the outermost shell is valency. And the valency of carbon is 4. So the valency of carbon is 4. Hmm. Now, like if I had to explain what valency is, like that means that carbon can bind or make bonds with other elements from or all four sides. Like it can make 4 bonds, right? This is how it would look. So this is my carbon. Give me 1 minute. So let's say this is my carbon. Now it had to it needs to bond with some other element. So it can make bonds on 4 sides. 1, 2, 3, 4. Like a different element can come attach on this side. Let's say element 1 wants to get bind with carbon. So it can bind from here, 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 and here also, right? Or there might be 3 of the same elements and 1 different element, or 2 same elements, and 1 new element is introduced. So it can bond like this, and it can even bond with all 4 different electrons. Here 1, 2, 3, 4 are different elements, right?
Yes.
1, 2, 3, and 4 are basically different elements. Hmm. So that means when in this point of valency, or when you'll have a question like why is it tetravalent, then you can also add like because it can also bind with 4 different electrons, or it can bind with electrons on 4 sides. Okay, now this is where the whole organic chemistry arises. Okay, so what happens is when carbon is there, I'm gonna erase. Okay, never mind. I'll make a new carbon. So this is my carbon, right? Now what happens is if hydrogen is attached on all 4 sides, so we will write. Can you tell me how can we write it as like CO2 is 1 carbon and 2 oxygen? How do you think I can write this?
CH4.
Yes, very good. So 1 carbon and 4 hydrogen, CH4, right? Now what happens is now carbon chain is comes into action. This is called methane. This is a hydrocarbon. Okay, hydrocarbon are from the name only you can tell hydro comes from hydrogen and carbon is from carbon only. So hydrocarbons. Now these hydrocarbons like are basically the whole organic chemistry here. The whole organic chemistry comes from here only. Now let's say this carbon, we are introducing carbon chain now. So it's only 1 carbon here. Let's say I have 2 carbons here. Okay, so now from one side, carbon is bonded with carbon on the one side. So now it can bind with 3 other elements because one side is already taken. So it will bind with again hydrogen because we're still on hydrocarbon. So it will bind with 3 other hydrogens. And on this side, because this carbon also has, again, this is also carbon. So it has 3 empty spaces. Again, it will bind with hydrogens. So it's the same thing as this, just 1 more carbon has increased. So it's C2 and count the number of edges 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah, C2 at 6. This is called as ethane. These are all gases. Okay. And now
Mm.
this, hmm.
Mom,
And
how is it called methane, ethane?
it's like it's decided from the scientists only. Like how is it called carbon, right? So people gave a name to this element. So similarly, that's why it's methane and ethane. There's no logic or science behind it.
Oh.
And you can keep on increasing the number of carbons. Like you can have 3 carbons, 4 carbons, 5 carbons, and it will keep on going on, right? Now if you might have heard about alcohols, right? So if
Yes,
the
ma'am.
whole thing is there and OH, if OH group, it's a new group. So if it's attached, so this becomes alcohol. So if it's attached in methane, this becomes methanol. And this goes on, like, so there are n number of possibilities when it comes to carbon. So it will just keep on going and going and going. Also, I don't know whether this hydrocarbon is in your, like, in this year, is it there in your chapter, hydrocarbons?
What, ma'am?
Hydrocarbons, do you have it in your chapter, in this chapter?
I guess.
Okay. Okay, so this was something extra. I don't know whether it's in your chapter or not, but this I wanted to explain. This you can make that carbon is bonded on 4 sides. Valency of carbon is 4. Done?
Yes, ma'am.
Okay, so the last point for the properties, the fifth point is the position of carbon in the periodic table, right? So the position of carbon. It's basically when you look at a periodic table, how you will be able to locate it, right? So in the periodic table. So carbon is the sixth element. So carbon is the sixth element and it is placed in group number 14. Sixth element. Have you seen a periodic table?
Yes, ma'am.
Mhm. So carbon is the sixth element and group in the group in which it's present is 14. So on the 14th group, sixth element is carbon. Done? So this was all about the properties. We started with carbon, went on about like its availability, how, where, and how, in which form is it present. Then we did a little about properties, like how does it look like, not look like, we are going to do that in the next topic, but the atomic mass, what is the weight, the number, and the valency, how it can bind with other elements, and also like how can you locate it in the periodic table. Now let's start a new topic. This is done for the properties. Let's start with the allotropes of carbon. Okay. So before going into like specifically allotropes of carbons, I want to explain what allotropes are. Do you know what allotropes are?
No.
Okay. So it's basically different physical forms in which an element can exist. So allotropes are basically of the same element, right? It's the same element that's occurring in different forms. So different physical form. All right, you can write this down. Now, other than carbon, there are a lot of elements that have their allotropes, like for example, phosphorus, silicon. So these elements also have exam. In examples, you can write carbon, of course, phosphorus, sulfur, silicon. Sulfur and silicon. Now, before like again going into the carbons, I'm going to tell a little bit about. So this phosphorus, when we talk about allotropes, so this phosphorus exists in basically two states or two forms. One is red phosphorus. It occurs as red phosphorus. I'll show you a picture also. Red phosphorus and white phosphorus. So it's basically they are different in colors. Color. Let me show you a picture. They also look different. It's not like they look the same and they're just different in colors. Different in color. They also look a little different. Let me show you one second. Till then you can write it down if you haven't written it. Hmm. So if I zoom in a little bit, so this is how red phosphorus looks like, and this is how white phosphorus looks like. So they're different.
Ma'am, it looks like tablets.
Yes, it does. Also, like if a little bit like crayons, a red crayon that has broken into smaller pieces. So that was about the allotropes of phosphorus. Now I don't want to. Okay, I'll tell you a little bit about it. So now the allotropes, there are three allotropes of carbon, graphite, diamond, and there's one more. I'll write the name. But we'll like go into the detail of about each of them in the next class because of the time. It's yeah, okay. So now you can just write down that carbon has three allotropes. All right. So these are the three states of carbons. Not states, allotropes of carbon, graphite, diamond, and Buckminster fullerenes. Uh, it's a big name, so just like you can break it down and then remember it. But we'll like go into the details in the next class because do you have another class?
No.
Okay, I do, so I'll have to go. So,
Um,
also like your question was the electrons are also changing. So why is it constant? Like I'll tell
yes.
down
Okay.
everything from today's
Um,
class. Yeah. Yes.
I
Yes.
have a doubt. Like, what are allotropes? Like, I didn't understand from the definition.
Okay. So I'll explain in this form only. So do you know what graphite is?
No.
Okay. 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 Uh, have you like used a wooden pencil
Yes, no.
or maybe a color pencil? So that lead the black part of the pencil from where you write down, right? So that's
Uh,
graphite.
oh,
Right.
okay.
So the meaning of them occurring in different form, carbon or an element occurring in different form. Basically, graphite is something that is very commonly used. Like you use it every day in your pencils. There is and it's very inexpensive. It's cheap, right? A pencil costs like 5 rupees. Whereas diamond is something that's very rare, right, and it's so expensive also. So
Mm,
from there you can like understand what allotropes are. It's basically they are made up of carbon, but when carbon has a different structure, carbon will have a different structure here and carbon will have different structure here in diamond and graphite. So and because of this different structure, the value and the composition basically it's going to be very different because like from graphite and diamond you can only understand the difference between the two, but we'll go into a little detail in the next class. So that will make it a little clear.
Ma'am,
Any
so basically it has different forms, right? Like
yes,
graphite and
yes, different structure you can say.
different
I'll
structure.
share the
Okay.
structure so you'll understand. Okay, fine. Done.
Yes, ma'am.
Okay, thank you for joining. Bye.
Bye, ma'am. Have a nice day.
See.